time in between. So that is the challenge. So welcome again. My name's Lane Martin. Again, I'm the department chair for material science engineering. There's a few other folks here that I want to take a second to introduce. Mary, do you want to say hello?
Sure. Hi, everyone. My name is Mary Scott. I am the Associate Chair for Undergraduate Studies in our department. So for matters of undergraduate curricula or class equivalency, things like that, or just questions about our course of study, I am the point of contact in addition to Medina Kozed in our front office.
And maybe with that segue, Medina, do you want to say hello real quick?
Yes, of course. Hi, everyone. My name is Medina. I am the undergraduate student services advisor in MSc. Kind of similar to Professor Scott, we kind of bounce ideas back off of each other, like the petitions, class changes, or like what do we usually work on? Research for credits. We go back and forth with students. And then also I'm here if you just have any questions on the undergrad side, or I can redirect you to someone who may be better to answer your question. But I'm always here for all our students, and thank you for joining us today.
Great, thanks. And then Daryl, would you like to say hello?
Unfortunately, I've got a bit of noise in the background, so sorry about that. I'm Daryl Shawn. I'm a professor in the department for 27 years and a former chair of the department, and I'm here largely for institutional knowledge. So I know a lot of what goes on in the department, and I can answer a lot of your questions as well.
Right. And I think that's the biggest point, right? So today is really about you all getting the information you need and want to have about the program. And we have a bit of a schedule, but it's very flexible, right? So if you all have questions and concerns and want to talk about things, we're very happy to spend more time on that. But otherwise, I'll give a quick overview of the department, a little bit of the history and where we are right now. Then Mary, Daryl, and I, and Medina will answer questions in that, for a while for you all, and then we'll hand it over to our very capable students who will make sure that you get a different perspective on things as well. I have the chat window open, so if you have a pressing question, you're welcome to chat that during the discussion, and we can talk it. You are also welcome to just say, "Hey, Lane, I have a question," and chime in as appropriate. And I jokingly tell the students that professors are programmed to speak uninterrupted for 1 hour at a time. So we like to be interrupted periodically. Otherwise, we'll just keep going. All right. So, okay. So let's get going. I think many of you probably have some feeling about Berkeley, maybe a little less feeling about material science. So let's jump into things. This is a beautiful picture of our campus, and I think we're one of the kind of cornerstones of that program. So when you think about Berkeley, you think about Cal. In fact, we just had a survey. The campus itself is trying to deal with the fact that there's this kind of dichotomy between Cal and Berkeley, and some people in the world don't know that these are the same places, right? But we are one and the same, right? So we have this excellence of academia, often codified under these kind of Berkeley emblems, and our athletics programs are quite good as well, often going under the Cal emblem, but it's all one place. And so it just goes to show you that you can do lots of good things at one place. All right, now we're going to go all the way back. This is a picture looking west. So out here, this is the bay. You can see maybe some of the islands in the bay just out here in the distance. So this is on the East Bay Hills, looking west out over Berkeley in 1874. So this is just a few years after the campus was officially started, and you can see that it looks a bit different than it does today at this time. But if you go all the way back to this time, you'll realize that MSE has historic roots on the campus. So the charter year for UC Berkeley overall was 1868. This came soon after what were called the land grant institutions, where the federal government granted land for institutions of higher education. So in the initial three colleges, one of them, the College of Mining, is the direct descendant we've come. All right. So MSE is pushing 154 years old, which for the US is, that's pretty good. Okay. That's about as old as it gets for an academic institution around here. Maybe not totally, but especially in California. Now, we also had some very influential people early on who have been instrumental in kind of the evolution of the program, including one of the earliest and most influential women in the history of the UC. This is Phoebe Apperson Hearst. So Phoebe Apperson Hearst was married to George Hearst, who was a well-known miner, and they had one son who you maybe have heard of. His name was William Randolph Hearst, as in the publishing magnate. But Phoebe herself did some really interesting and important things. She was the first woman regent of the UCs overall. She funded some of the original scholarships for women at Cal. And something that's really important for us is she funded a competition for, quote, a campus architectural plan early on in the 1890s. And this is where our building comes from, which you can kind of see behind me in this picture. And there's some fun quotes that we like to sprinkle around in here just to give you a sense of the time and what was happening. And so I think many of us know about Oxford University, a very well-known university in the world, very beautiful place. And there's a quote here from from a Latin order that I think is very fun. It says, "There is brought a report that in California there is already established a university furnished with so great resources that even the architects, a lavish kind of men, full permission has been given to spare no expense. Amidst the most pleasant hills on the elevated site, commanding a wide sea view, is to be placed a home of universal science and a seat of the muses." If only we wrote this elegantly nowadays when we write these sorts of things. But this is a sense of what we have in Berkeley. It's a nice place to come to do your studies and do your work. Now, what Phoebe Apperson Hearst did is she funded this architectural plan, and in that process, they selected John Galen Howard to build a set of buildings on campus. And so, if you walk around campus, some of the buildings that are the most kind of archetypal for the UC campus here, for Berkeley's campus, were designed by John Galen Howard. So they funded him with roughly $900,000, which is a bargain in today's dollars. That's only $22 million to erect the first few buildings under this architectural plan. And they built one building, which is the Hearst Memorial Mining Building. Its cornerstone was 1906. This is a picture of it in 1909. It was dedicated in memory of George Hearst, a plain, honest man and a good miner. And this has been kind of a bellwether for the campus. It's been here for the whole time, right? So you can evolve through the years, and other than maybe changing the types of cars, going from having no cars to having old cars to having slightly less old cars to having more modern cars, Hearst Mining has remained this kind of beautiful building on campus as the campus is built up around it. All right, so it was dedicated. Sorry, I think I said cornerstone was 1906. It was 1902, and then it was dedicated. It was finished in 1906 and dedicated in 1907, and then it went through a large upgrade in the late 90s, early 2000s, and formally reopened just about 20 years ago. So it's been modernized since this time. Now, it's a beautiful place to come, nice place to call home. This is a picture of our lobby, which if you come to join us next year, this would be a great place to come and spend some time. We often have people. You can see there's even, in this picture, there's a picture of a person taking a picture, right? So that's some sort of metaphysical, I don't know, conundrum here. But lots of people come here to draw and kind of experience this wonderful place. So this is the lobby, and it was designed in the spirit of the National Library in Paris, this reading room there. So it has some sense of the same. This is just another picture of the lobby. This is a picture of our student bay where some of our student offices are and things like this. It's a very nice, open, airy kind of place to come and join. Okay, a little bit more history here. Ludwig Eduard Boltzmann, who was a very famous Austrian physicist and philosopher, and I guess statistical mechanician is the appropriate term. And many of you may have heard of Boltzmann because of his famous constant that we use in many expressions. He visited and taught at Berkeley during the summer of 1905, and he has some very fun things to say about Berkeley. So first, he called it the loveliest place one can imagine. And we can never take an opportunity to not give it to our colleagues and neighbors across the bay. And he said the following. He said, unlike Berkeley, Stanford University is laid out in a unified, architecturally attractive scheme that seems to me quite unsuitable for educational purposes. It's timeless statement. We feel somewhat similar, and we think that Berkeley is really the place to come, and so did Boltzmann. All right. So enough about the history. Now let's get up to the modern day. So what's our promise to you as a department, right? And this is kind of a little bit of our spirit and ethos here. So what we want to do is work with you to make you the best possible material scientists and engineers that you can be, right? The best version of yourself that we can. We're going to work within the constraints that arise, if any do, to provide you the best access and support that we can for your education. And while we're doing that, we're going to work to provide a safe, caring, and humane environment that enables every member of our community to grow and thrive. This is really important for us. And ultimately, what we're really trying to do is seek a diverse student body, a diverse faculty, a diverse staff, and a diverse perspective on the problems that we're trying to solve, because we believe that that's a critical part of the mission of educating leaders and in serving society as scientists and engineers, right? So hopefully this gives you a sense of the kind of the spirit that we're coming at the educational process with. All right, so what is this program that hopefully you're going to join us in? Where are we at? Well, we have the combination of things going for us that are pretty good, right? So we should take these rankings with a grain of salt, but they are an indicator of kind of perception and reality of what's happening at the university. So we are the #1 public university in the country and in the world, and ranked very highly according to various different rankings. The College of Engineering is ranked very highly as well, both for undergraduate and our graduate education. And those two things are very important. We want to be strong in both of them. And we'll talk about that in just a moment. And then if you look at the department rankings, here I have going back maybe 5 or 6 years for the different areas, both on our undergraduate and graduate level, we are ranked generally in the top 2 or 3 in the last few years. So very, very strong. What we're hoping to do is provide students this opportunity to get kind of cutting edge education, learning new and interesting things that's grounded in this kind of critical foundation of concepts. We're mixing in state of the art new things with the traditional foundation that you need to have, and doing that across a whole bunch of different areas of material science. Okay, so who would you be joining? Well, we have great students. We have about 315 total students in the program right now. That includes about just about 46% undergraduates with an incoming class size that's typically right now we're aiming to be in the range of between about 50 and 60 for incoming classes. That's both first year students and also transfer students coming in. Now, the vast majority of those students, out of the 145, it's something like 123, are coming in straight into our individual BS program, and we have another maybe 20 or so students in the joint majors with other departments as well. Now, the other half of the department, or a little more than half of the department, is our graduate program. Incoming class sizes are anywhere between 45 and 60 students, and those are spread out across 3 different groups. One is our PhD students, which is the vast majority of this, somewhere in the ballpark of 20 to 30 a year. MS students, so Masters of Science students, somewhere in the ballpark of 10-ish a year. And then MN students, which is a different type of master's degree that you can tap into. I will also point out that these MS students are our own undergraduates who stay for a special 1-year master's program. It's called the 5th year BSMS. So if you finish your bachelor's degree in our department, you can stay and in 1 year finish a really high touch, a really high quality program where you can get your master's degree. It's very effective and it's a really great program. I really recommend it a lot. In terms of the class makeup, just to give you a sense, we're in the ballpark of about 35% female students across the board, which is good compared to the national average in material science and in engineering overall. But of course, it's something we're continuing to work on, not just in the department, but also at the college and campus level as we try to diversify that student body even more. Okay. All right. So once you're here, who are you going to interact with? Well, you're going to interact with a set of really great and outstanding educators, and you can see their smiling faces here in these pictures. We have 19 core faculty. You can see the breakdown of those things on the side, and these faculty are very highly regarded in their fields as experts and really world leaders. Some of these things show up in terms of their election into the National Academies of Engineering and Science, various awards. This is the Presidential Early Career Award for Science and Engineering. We have MacArthur Geniuses, and we have people who have been considered deemed to be fellows of their various specialty fields. Now, we also have strong connections with the national lab. So if you don't know, right next door to UC Berkeley, just up on the hillside, is Lawrence Berkeley National Lab, which is a world-class Department of Energy supported research facility where we have a number of our faculty who serve in director roles, really kind of intertwining this big scale DOE science with the kind of education and research we do in our own department. Now, in addition to the core faculty, we have a handful of joint faculties or faculty who primarily live in another department but do material sciencey things, and so we engage with them. They can advise students and participate in their education. Because we have Lawrence Berkeley National Lab right next door, we also take advantage of something called adjunct faculty. These are typically people who have staff scientist appointments at the national lab, and in turn, can teach and advise students here on campus as well. We have a set of lecturers who really do a great job of covering our laboratory classes and lecturing some of our courses. And of course, we have what are called emeritus faculty. These are faculty who have since retired, but are still actively engaged on campus. The take-home message from all this is that you're really going to have an opportunity to work with the leaders in the field, right? In many shapes and forms, both in education and in research. We also have a whole set of people who are focused on providing services for you as students, right? And we have a couple of folks dedicated to serving as student service advisors. In particular, you already met Medina, who I've starred here. Medina is our undergraduate student services advisor. These are people who can really be an advocate for you. They're kind of the one-stop shop for all your academic needs. So you can come to them and they'll try to get you to the right people and make sure stuff gets sorted out. We also have a group of advisors. These advisors are available to meet with you and talk about anything you want to talk to about your classes, what you should take. I want to do an internship. I want to do this. I want to do that. They can help you navigate these sorts of things. If you're thinking about graduate school, this is a good place to start too. And Mary, who you've also met, is kind of oversees all of these sorts of programs. Then this is all backed up by what is called Engineering Student Services, or ESS, which is a College of Engineering wide organization that provides a whole another level of support in this regard. So there's really a lot of resources for this. Okay, looking a little more broadly, we have other staff members who really support these sorts of things. You can see their kind of smiling faces here. Everybody who cover everything from kind of appointments and personnel and finance matters to student services, folks doing more technically focused things, and even people looking after the building and safety and all these sorts of things. So there's a lot of support around for these matters. All right, now what you're seeing here is what we call kind of the curriculum map. This is kind of a one-page summary of everything that you would have to take to finish your degree. Now, since you all would be coming in from the community college program, you can pretty much assume most of the stuff on the left side here, you're going to have taken care of in some shape or form. Maybe some of the upper division material science courses you won't have, but a lot of the electives and things like this, you will have perhaps taken care of, and a lot of the basic courses you'll have taken care of. We have designed this curriculum with a couple of things in mind. One is that whether a person's coming in from a community college as a transfer student or coming in as a first-year freshman student, they should be able to finish this in 4 years if they have no other credit, right? And so for a transfer student, the idea is hopefully you'll come in and finish this pretty reasonably in 2 years after you get here. The second part of our plan here was to open up a lot of choice for you as students, right? So if you look in particular on the right-hand side here, you'll see a lot of electives. There's entire semesters that are almost all electives. And this is really designed to give you as students the opportunity to kind of dictate what directions you want to go overall. And give you the flexibility to take classes when you need to fill these sorts of things in. You want to take engineering or technical classes for these electives? Great. You want to take something more broad to give you a little bit of broader base? Also great. It's really kind of up to you as a student. We also work to specifically try to do things that make it a little bit easier for students to transfer in. So if you ever have an issue or a question here, this is something, just bring it up. We can talk about it. There are ways to deal with these things on a case-by-case basis as they come up. I'm noting that there's a couple questions have showed up. There's one about the master's degree. How about I come back to that once we knock out a few more things, and I'll answer that. But if there's other questions, you can keep putting them in there and I'll address them as they come up. From the educational point of view, we're also doing a lot on innovating in education. We have people who really spend a lot of time on these sorts of things. How do we improve what we're doing inside the classroom? And we even hosted kind of national symposia on materials education, for various people in the community over the years. Okay, another thing that I would really highlight for you is, looking into research. So if you're going to come to Berkeley as a student who's going to spend all 4 years, or coming in as a student from a community college who's only going to maybe spend a couple years here, one of the biggest advantages to being at a place like Berkeley is taking advantage of the things outside of the classroom, right? And one of the things that we have to offer is this world-class research. We have pretty extensive research expenditures inside of the department across all of our faculty, and strong efforts across a whole bunch of different areas. Really getting into the lab, spending some time with graduate students, postdocs, and with the faculty will give you a perspective on those things you're learning in class that is really priceless and you can't get in other ways, right? So I know you're very busy when you come in as a transfer student, but if you can find time to make a little bit of time for these sorts of opportunities, I really think they can be quite productive. Okay. You can then also tap into all the resources the campus has. We have specialty facilities where we have shared equipment, like the nanofabrication facility and something called QB3 in Stanley Hall, which is literally right next door to us. We have microscopy facilities and things like this. And then, as I mentioned before, right next door up on the hill is the Lawrence Berkeley National Laboratory, where you can get involved in things, not just on the laboratory scale, but on, the football field size scale of research, right? So this is a synchrotron. Mary is an expert in atomic resolution electron microscopy. So there's the National Center for Electron Microscopy, which is part of a bigger nano center called the Molecular Foundry. There are world-class computing facilities. Daryl and others take advantage of these sorts of things. You can find whatever you want, right? And you can find a world expert in that space and make an impact. And again, I want to point out that there are opportunities for students to be involved in many, many, many groups in our department and outside of our department, right? Berkeley is really about, melding these two things together. You can access these facilities, you can find opportunities, and really, take your education into kind of overdrive on these sorts of things. So if you want to talk a little bit, sorry about that. If you want to talk a little bit about how we get into this, maybe we can save that for the discussion, but we can give you our own take on these sorts of things as well. But it's really about communicating with the faculty and the groups. And so maybe as a final statement here before we answer some of the questions, I think the advantage to material science at a place like Berkeley is you get the benefit of something like a small school, right? We have this small kind of intimate program, lots of people know each other, but you also get the benefits of the big school environment of Berkeley, right? So you have all these things and clubs and activities going on, but your department is pretty close-knit and well connected. There's lots of peer-to-peer support from our student organization. We have our own in-house advising and mentoring and all these sorts of things. And really, it's an opportunity for you to kind of find your way in the world and in the field, and really do some great things here. And before you know it, you'll be at the end, right? And it's a pretty joyous occasion, to see everybody kind of walk across the stage and graduate. So, it's really a wonderful place here at Berkeley and in MSE, and we hope that you'll join us here and kind of write a new chapter of the history of material science at Berkeley, right? So that's kind of our overview. So let me stop sharing here, and I will take some of the questions that came in, and we'll be happy to answer more questions. And Mary and Daryl will chime in as appropriate, and Medina as well. Okay, so one of the questions that came in was, why would students get 1 year to complete their master's degree? What happens if you don't complete your master's degree in 1 year when you are in the BS and MS degree program? So there's a special curriculum that's developed that we put together for this 5th year BS MS. And the real kind of logic behind it is that we know what you've taken, right? You've taken much of your material science curriculum through us, right? So you've taken our courses and our thermodynamics and all of these sorts of things. That means we have some kind of quality control. We have some expectation of the understanding that you have. We have then created a slimmed down version of the master's degree that allows you to complete the courses in 1 year, and it includes a research topic as well. In addition to you doing research and taking classes, there's also a small course, like a seminar type course, where you have an outside mentor who really helps guide you through that process. So when I was calling it a high touch kind of program, it really comes from that additional, connection. We also do some career development things along the way. So because you're staying in the program here, perhaps you have some connections and all these sorts of things that allow you to kind of hit the ground running quicker. We can get it done in about a year overall. And so it really is an advantage, because if you move to a different university, you would typically take you 2 years to finish that same master's degree. Hopefully that answers that question. There's another question. I can come back to anything if people want to, and Mary and Daryl chime in if I'm missing anything. Okay, how would double majoring work in an engineering curriculum or course? Okay, so there's different types of things. So there are true double majors and there are joint majors. A true double major is basically I take everything from major A and I take everything from major B. That is a lot of work and would take quite a bit of time. There are people who do that, but I don't know. My general advice would be, to really have a conversation with you to understand why you want to do something like that, what you think you get out of it, and see if there's like maybe a slightly less overwhelming or stressful way to accomplish something similar. Coming in with from a community college and trying to do a double major, I'm pretty sure that I think maybe Nicole or others can chime in as well. I think that may not be allowed to come directly into a double major. Does anybody remember that off the top of their head?
I think you're right, Lane. I've never seen that happen.
Yeah, me either. So then in material science and in the College of Engineering in particular, I should say, we have a second set of things which are called joint majors. And the joint majors are, it's like a negotiated major, right? So, chemical, let's say, mechanical engineering and material science sat down and said, okay, what are the things that we can assume we have kind of overlapping, right? So thermodynamics is thermodynamics, whether I'm in mechanical or I'm in material science. So we don't have to take two of those, we can take one of those. And we find these kind of common grounds. And we've articulated different joint majors that are less than a double major in terms of total number of courses, but give you an exposure to both programs. This has gone back and forth. Historically, transfer students could come into these. Then it was deemed that transfer students could not come into these programs because it added a bit too much additional work for them. Mary, do you know if that's still the case? Daryl too?
Nicole just wrote on the chat. That's how I know that you can now come into a joint major.
You can come back into the joint majors now.
We're directly into it.
For transfer students, you have to apply to one of the majors. So for example, I would apply to Berkeley as a material science student, and then you can add the joint major once you've matriculated, if you can complete it on time. Versus the double major is just not an option for transfer students in the College of Engineering.
Yeah, thank you, Nicole. And you can tell this is something that we continually thinking about, because it has evolved back and forth over the last few years, and that's why we have people like Nicole who are experts to keep us on task. Okay. Another question was, is the 1-year MS considered a terminal degree? Yeah, I think so, right? So you have your BS, you'll get your BS degree. You can stay for the MS degree. If you wanted to continue on into, say, the PhD program, we would have you apply for the PhD program formally the next time around. And we do see some students who want to go straight from there, who maybe aren't sure what they want to do, and they'll do the 1-year master's and then decide to go, on to a PhD, or some folks will go out to industry or whatever. But we will have you apply for further degrees if you were going to do that.
And just echoing that, it's a really great way to get a taste of graduate level research, and that research can be performed in a lab at UC Berkeley. It can also be performed collaboratively with an industry partner if you happen to have that. So that can be
And at LBL, you can do it
Yeah,
at
and at
LBL
and at
with the
LBL.
staff scientists. We have that with some frequency as well.
Yep.
Okay, so I answered the I think a handful of the questions that are there. Are there other questions that people have right now that we should address? You're just chime in if you have them. Okay, we'll be ready to answer questions, but we also have, you know, Mary and Daryl and myself here. Oh, here's one that just came in. Sorry. Okay, if you have another major, can you still seek help from material science faculty? Yeah, I mean, at some level, right? So like each department is going to have a set of their own, you know, support structures, right? So they're going to have their own student services advisors. They're going to have their own, you know, kind of approaches to dealing with the advice you need. Now, if you're asking about something academic, about some other department, the faculty in material science probably aren't going to know very, very well what's going on in some other department. But if you're asking about research, if you're asking about graduate school and things like this, then yes, absolutely, right? I think the faculty are generally trying to help, you know, are happy to help people find their own way, right? And people are always happy to talk about themselves, right? So if you can bring it up and talk about like, hey, how did you get there? And what did, you know, how do I know what I want to do? Like people are happy to kind of share those kinds of experiences with you. So I think in particular, you know, material science often has the challenge that people don't know about it until it's too late, right? In the grand scheme of things for them to do it. And so they come to us late in the game, and we often will try to figure out ways that they can connect and be part of that, you know, part of the field, you know, at different ways, right? Maybe you're not going to fully major in it, but maybe there's a way you can do a minor, or maybe you can do research in material science, even if you're coming from another discipline, and that'll drive you towards, you know, career choices and or industries or graduate programs in material science, right? There's no right or wrong way to get into it, right? We just like we're passionate about our field, and we hope everybody else is too, right?
If I can have just one brief
Please.
addition, and clarification, or I mean emphasis, I should say. You do not have to be a material science student to do research with a material science faculty member, nor do you have to be a physics student to do research with a physics faculty member, et cetera, right? So once you're a student here, doing research with whomever you wish to do so, provided that that person agrees, is possible, right? So we have, in all of our groups, I expect we have students from other departments, or have had students from other departments, and our students in our department go and work for students in, I mean, for faculty in electrical engineering and mechanical engineering and bioengineering and things like that. So the research opportunities are much more broad than simply within the department. And let me also emphasize that the way one gets one of these research jobs is not how you might think. All of us as faculty are really eager to have undergraduates doing research in our programs. They bring a sort of a special view of things that actually is helpful, and so we don't typically advertise jobs for these things. What typically happens is a student comes and approaches us and says, "Hey, I really would like to work on what you're working on, or I'd like to hear about it." And after that discussion, if that progresses favorably, the faculty member finds a way to pay the student a small amount to come do research in the group. So when you're looking, when you arrive and you're interested in research, you have to start reaching out to faculty. Like I said, they're not going to advertise jobs. And this is true, I think, across the college and probably across the campus, to be quite honest. And so you have to be a little bit, not aggressive isn't the right word, but you have to be willing to put yourself out there and start to talk with faculty. And that's how you will find a research job. And the research jobs, I mean, that's what we really take pride in here, right? You know, in courses, we teach you how to solve a lot of problems that have been solved already. But research is where you learn how to solve a problem that's not been solved. And that turns out to be what your job will be like when you get out, irrespective if you end up in academia, industry, or you know, government labs, something like that. So it's a really really good experience, a really good educational experience, and it really will give you a feel for what this discipline is all about. So.
So with that said, maybe we'll just open it up here. So we have the 3 faculty members here. We're very happy to answer questions. We're happy to tell you about how we got to material science. We're happy to tell you about our research. I mean, like I said, it's really up to you all. What do you want to know about, and what are you curious about? And then, you know, we'll launch into it.
Would you guys be willing to, you know, having mentored some students who are community college transfer students in my group. So I've had researchers in my group who transferred in. If you guys are particularly interested in that, and maybe I'll just say this unprompted. But you know, when you transfer into Berkeley, you're on a bit of a tight timeline. You know, you just physically have less time here than some of the other students. I think like Daryl was saying, you know, it's worth it to be kind of put yourself out there and write emails if you're interested in research. And also don't be shy and feel like just because you're working for a professor during the school year, like you can't also look for internships over a summer, for example. I very much understand that students who want to go on to graduate work or want to go on to an industry job where, you know, having that multiple types of experience is helpful. They might go do something different over the summer, and that's completely fine.
And in fact, I think a lot of us would advise that, right? Like, how would you know if industry is what you want to do if you've never gotten an experience there?
We're
right?
always very happy to write letters of rec and things like
Yeah.
that, and even give you our recommendations for where you might poke around for opportunities. So it's definitely worth it to advocate for yourself if that's something you're interested in. And we are always happy to kind of give you generic advice, not just about working in our own labs to that end.
The other thing about the environment within the department that I think Lane touched on is that we have a very active undergraduate student group that you're going to hear from, I think, at the end of this presentation. Is that right?
I think so, yes. Yeah.
Right. So they'll give you the lowdown on what really goes on. I mean, we know what we think really goes on, but they actually experience it day to day. So you can ask them very direct questions, and I'm sure they'll be happy to answer. But they also serve as an incredible resource for the newer students coming into the department, because it's this community of folks who have gone through a bit of the department, the undergraduate, the lower division courses. And so they'll be a really good resource for you when you get here, to help you set up study groups and just to get to know people and feel like you're a part of the Berkeley experience.
And also the college does a lot too, right? There's a I think everybody top to bottom really, we have a special system with this, with the community colleges and the connections to the UC in California. And I think we've had many good experiences with students who transfer in and come from community colleges. We have some of our own faculty and lecturers who have done this in their own lives over the years. And so we want there to be a supporting network and structure for that transfer to happen. All right, so any questions? I know I'm very informative, but I'm not that informed. All right, maybe while people are thinking about it, maybe Mary, why don't Mary and Daryl, why don't you tell us how you ended up in material science, right? Maybe we'll spark some interest with some stories here.
Yeah, for sure. And this might resonate with people who are asking questions about like double and joint majors, because my background is like always orbiting around material science, but only more recently I find my way officially to a material science department. So I grew up in North Carolina, actually, in a pretty small town, kind of in the middle of nowhere, literally almost in the geographical center of the state. And so I did my undergraduate at North Carolina State University, and I was interested in engineering or some technical field. And I went to a really small high school. Like, we didn't have a lot of like technical classes. I never took physics until college. I actually started off as an aerospace engineering major. and then added a physics major because I realized I was just way more interested in solving more fundamental problems than we were getting to kind of in the later coursework of aerospace engineering. I kind of realized I loved aerodynamics and I loved the math that's used to describe that physics, but I was less interested in, designing system controls for airplanes. So at the same time, I started doing undergraduate research. Actually, I started off as a, what we would call at Berkeley as a reader. So I was grading homeworks for professors. And then I ended up joining one of their labs. That's another way to get to know professors and also to earn some money if positions are available. And I fell in love with research. So I ended up doing my PhD, applying for my PhD. I'm kind of inspired by that. I went to UCLA and I got a PhD in physics. However, my PhD research always centered around materials characterization. I consider myself an electron microscopist that studies nanomaterials. So my PhD work was all about electron microscopy and all about materials characterization. And because my specific specialty really centers around studying imperfections in materials and on the nanoscale, how do they influence the way those materials behave and transform when we use them? That is material science. So I was always on this trajectory and always really performing material science research, even though my PhD was in physics. So it was very natural for me to then pursue a position in the material science department. The job that I applied for is actually, specifically looking for someone who develops new characterization methods. And that really was my passion. I knew I had to go all in on that job application. And I couldn't be more spoiled because we, in addition to the wonderful faculty and environment that we have at UC Berkeley, we have amazing electron microscopy facilities, probably some of the best in the world, at just up the hill at LBL. So it's a really, really great environment to mentor students. They get to, interface not just with the equipment, but with all the other staff scientists that are experts at the microscopy facility, which is the National Center for Electron Microscopy. So I call it NCEM up at LBL. And I think that's not unique to me. Many professors in our department, I would almost all have some sort of affiliation up at LBL. Mine is strictly 50-50. Others have different percentages and obligations up the hill. But that means that it's pretty easy for students, even at the undergraduate level, to do research at that national facility. So that's pretty special. So that turned into me sort of talking about the wonderful research environment here, but that's also kind of my background. So I think me and Daryl are both reformed physicists.
Yeah, maybe before Daryl jumps in, I will just piggyback on what Mary said. We often have students, both undergraduate and graduate students, who go up and use the National Lab facility. We even had students, undergraduate students, who will do synchrotron shifts with us, right? So they will be trained. They will use this giant $25 million end station for a beam line. They will be the only person in the world allowed to use it that day, right? And they get to do it, and they get to participate in analyzing the data and measuring the samples and writing the papers and things like this. It really is a pretty special opportunity having these facilities and resources right next door. All right, Daryl.
All right, so my story is maybe a little bit different than Mary's. I came from my father was a surgeon, so I was around, my brother's an anesthesiologist. I've got doctors everywhere in my family. So when I was, sort of the latter years of high school, I was telling everyone I was going to be a doctor. And I was taking physics at the time, and we started learning about special relativity. And I thought special relativity was the most weird thing I'd ever heard. And it was more, fantastical than anything I'd seen in science fiction, and yet it was reality. That things got heavier when they moved faster. That's crazy. And that yardstick somehow got shorter when they moved faster. That was insane. So I knew right then and there I wanted to do something in science because I found this fascinating. So I graduated from high school and I went to Northwestern and they had a program called Integrated Science, which was basically an attempt to tear down the boundaries between various scientific disciplines. And so I went through that program, and I think it taught me to appreciate science as a whole rather than as individual disciplines, which allowed me to be relatively fluid in going from physics to material science ultimately. So I went through, I entered a graduate school actually in the physics department of Berkeley. I worked for a man who came within 1 electron of a Nobel Prize. Someday I can tell you that story, but it was he was an amazing guy. So when I applied to Berkeley, I decided I wanted to work in astrophysics. But I got married immediately after undergrad, and I didn't think I would make any money as an astrophysicist. So I decided that good science is where you find it. And so I became, I started looking at condensed matter physics. So I became a condensed matter theorist, and I graduated by studying in my physics curriculum, much like Mary said, I actually was studying materials problems. So I was looking at alloy behavior, order disorder transitions. I was looking at spin waves on the surface of semiconducting magnetic semiconductors, and that led my advisor to say, well, you should really look at material science departments. And so I went off to a national lab for a while to work with what was at the time, I believe, the premier computational material science group in the world. It sort of gave us techniques that have become workhorses of what we do now, at least at very large scales. And so I learned a little bit about material science, and I ended up back here as a professor in the material science department, and I haven't looked back. So that was 27 years ago I joined the department. And it's been really wonderful to watch all the young people like Lane and Mary and their cohort come up and watch them change the world. It's been a lot of fun. And I just, it's a calling for me. So I knew I was going to do this. I also had this little difficulty that I told my wife, my now wife, who was my girlfriend there, I was going to be a doctor. And I ran into sort of an issue when I wasn't going to be a doctor, but then I found a loophole. So the philosophical doctorate degree allowed me to get through it. So I was able to maintain my relationship with my now wife, which is good, and still become a doctor. So I wasn't a liar, but still be able to study these crazy scientific things that I like to study. So relativity is fascinating, but I got to tell you, how a metal bends is also fascinating in its own right, and also equally complicated. And that's what I study for a living. So I do theory, materials theory. This department, I would say, this is going to sound a little boastful, but I would argue this department has the best computational material science program in the world. We have, there are 5 of us that work, 6 of us that work exclusively in theory. And some of my colleagues have founded something called the Materials Project. If you're bored someday, go to materialsproject.org and see what that is. It's basically a database of every computed property of everything we can think of. That sounds grandiose, but it really is what it's aimed at. So I'm in an environment that a theorist can only dream about. We have incredible experiments, really easy to communicate with people doing these incredible experiments. And then we have all the tools we could ever want to develop theories to understand how nature is working. And it's just a dream job for me. I get paid for doing algebra. I know many of you probably don't like to do algebra, but if you're twisted and you like to do algebra, I get paid for doing algebra. So it's pretty cool.
Thanks, Mary. Thanks, Daryl. Before I give a similar background, any questions here? We don't want to just talk. We want to make sure we're answering your questions. So we don't bite, I promise. Okay, if you have questions, please chime in. All right, I'll give you my pathway to material science. I might be the only one of the 3 of us who I have a bachelor's, a master's, and a PhD, all in material science and engineering, but it came very close to not being that case at all. So I am from rural Pennsylvania, and I ran out of classes to take when I was in high school, my senior year. There were 8 periods. I had 5 study labs because we just didn't have anything for me to take at that point. So I liked chemistry and I liked math. So I was like, I will be a chemical engineer. But where I'm from, nobody knew what that was. And I didn't even know material science was a thing. So I went to Carnegie Mellon for undergrad. and I started as a chemical engineer in fall of my freshman year. And I will just say that there was a mutual dislike. I didn't like chemical engineering, and chemical engineering didn't like me. I didn't. No disrespect to our chemical engineering brethren and friends, but I felt like a glorified plumber doing chemical engineering in the intro class. It was all pipes in and pipes out, and I wanted to know what was happening inside the reactor, right? So my friends were a number of my friends were business majors, and they were like, "Hey, Lane, you can do calculus, so you should become a business major, and you can do all our homework for us." That was the pitch I got from my business major friends. So I was not sure what to do. So I talked to my randomly assigned advisor, and that advisor told me, well, he said, "Hey, well, what do you like actually like?" So I explained what I thought chemical engineering was going to be, and he's like, "Oh, well, you want to be a material scientist?" And I was like, "I've never heard of that." So he called the department chair for material science, sent me over there, talked to him. I was like, "This sounds pretty good." So I decided I would take the intro class to material science in the spring of my freshman year, but I was concerned that I was perhaps not well suited to being a scientist or engineer. And so I said, I'm going to do it a whole hog. I'm going to go and do research, and I'm going to take the class, and I'm going to do everything. So I just like randomly picked something. They had some descriptions of research positions that were open. One had something about large lasers, and I was like, yeah, done. You had me at large lasers. I will do that. So the research I started doing spring of my freshman year is not too far from what my research group does today. So whereas like the fit for me with chemical engineering was poor, the fit with material science was bang on, right? The way a material scientist thought about a problem is the way my brain was naturally wired, right? And so a lot of it just kind of made sense to me. Like I would think about the problems in the same way and go about solving the problems in the same way a material scientist did. And so for me, it was really about finding that place where I felt like my own skill sets and my own capabilities were, helpful, right, and useful in this regard. So I did research. Like Mary said, I tried to do a little bit of everything. I spent a summer at a company. I did research during semesters. I spent a summer at a national lab. These all opened up really interesting, experiences, and helped me make an informed decision about graduate school. And I went on from there to do these sorts of things. So that's how I ended up as a material scientist, and it's a pretty great job, right? It's a pretty good pretty good field to be in. Okay. Any other questions? Curriculum things, nuts and boltsy things, you know, you
Then you
want
might want to
Mary?
talk, I don't know if you have any data on the salaries that folks get, but I think the graduating salaries are up sort of one of the highest of all the engineering majors in the
Yeah,
college, only
generally,
beaten by CS
yeah,
actually.
generally in the ballpark of being like typically second, just behind the CS majors. It depends. The numbers I have are a little bit old, but I would say it's not unexpected for students to end up straight out of the bachelor's degree in the ballpark of like, I would say 85 to 100K. And we see if students go on to a master's and to a PhD, you can kind of give a little multiplier to that number, and there's kind of a couple different kicks up. Um, by the time people sometimes get their PhD and move into some of the bigger tech companies and things like this, that salary might be 150K plus 50K stock options and signing bonuses and higher, right? So it's a pretty lucrative field. At the end of the day, it makes sense. Anybody who makes anything has material science, right? Even if they're not famous for having that, they have material scientists who work there. So if they're making any actual products, they will have material scientists.
And at the peak of your career, you can actually make enough money to live in the Bay Area, which is
Yes, that is true.
which is true. So I mean, these are the starting salaries Lane is talking about, but you
Yeah,
could,
straight out of the degrees, right?
but when you make it, when you've been working for a few years like I have, you can actually have enough money to, like I said, live here, which is nice. That's something we all sort of want, I think, as we're growing through life. We'd like to have a nice home life, and you can do that this way.
That's true. That's true. Okay. Medina, are the students here?
I am not seeing any of them yet.
Okay.
So, don't know what's happening.
Yeah, and it could be that there was a snafu with the Zoom link. So, okay,
Possibly.
with that said, are there any last questions while we sort out this last transition for Mary or Daryl or myself on things? Okay, so look, at the end of the day, let me just say that, you know, we really value uh, all of our students, but we've had great experiences with transfer students coming into the program, and we really want to be a welcoming and a place and location for those students who come in. We really think it's you know, a great opportunity to do some awesome work and a place to finish your degree. So we hope you take the opportunity to join us in this regard. Oh, I think there's some questions coming in. So there's one about summer opportunities, and somebody said, "Hi, I have a question." So, are there summer opportunities for research or internships? Yes, tons. Lots of companies are looking for interns. We often even have job fairs that are specific to our field in this regard, run by one of our you know, lecturers. But there are lots of opportunities. There are summer research programs at universities, at national labs, and in industry. There are tons of options in that regard.
But also the research efforts with the faculty. Typically, when I hire an undergraduate, I'd like them to stick around for the summer and work on their project.
Right.
That's
right.
Those are meant to be sort of year round.
Exactly. And we often, like, I pay the students who stay in the summer, so they have a paid research
Yeah,
opportunity.
that's what I do too.
Yeah. I think someone else said, "Hi, I have a question." Do you want to chime in?
You can just turn your mic on and ask too.
Yeah, you're welcome to just verbally ask. You don't have to type. Okay, while that one's coming in, somebody's saying, "What's the best way to get in contact with professors and faculty?" Email works, but we get a lot of them. So don't be shy about following up on those sorts of things. Office hours are great. You know, come to office hours, talk with people, talk to your instructors after class. Even if your instructor isn't the right person, they will often connect you with the right person. We do this all the time in classes. If somebody comes and says, "Oh, that thing you talk about is really cool, you know, who's doing work like this?" Then we put you in touch with those people who are doing these sorts of things, right? Another great way is to talk to their graduate students too, right? Maybe you meet them as GSIs in a course, or you run into them in other ways. That's another great way to come in and make a connection in these regards. But I think it's just about communicating overall and building those connections and relationships.
Hi.
Hi.
Hi, sorry, my mic wasn't working earlier.
That's okay. You're good now.
Okay, my name's Carrie. I currently go to El Camino. This is kind of a question geared to getting prepared for like my research experience at Berkeley.
Sure.
So I'm participating in a research conference and I'm like brainstorming ideas and research topics. And so like as faculty members and just like experienced people, are there any suggestions on things you think I should get started on before I get there, kind of to like get my feet wet and like, you know, not be so intimidated, I guess, when I get there?
Yeah, I think the first thing to realize is that everybody starts at the same level, right? We started there. I didn't even know what material science was, right? Like that's about as basic as it gets. So just keep in mind that everybody starts there and we're all trying to learn. Like I'm still learning as we go, and so so is everybody else, right? So I would say start with the things you're interested in, right? If there's like, if you really think, man, doing, you know, simulating in a computer how these things do this, that, or the other seems awesome to me, and I want to do something like that. Well, read up on what people are doing in this regard. Talk to people like Daryl and say like, hey, what can people do nowadays? How, like, what's the limits of these sorts of things? You know, just start with simple, innocent questions, and often it'll lead to really insightful kinds of of approaches to doing these sorts of things. So I would say just start with the stuff you're interested in and learn about that, read some papers. And if you don't understand everything, circle the words, underline it, and ask follow-up questions with people about those things. Like, people are very happy to help you, like, learn how to talk the lingo, right? And part of it is about getting the lingo, right? And that takes some time. But people will help. Mary, Daryl, others.
Yeah, I think it's, oh, go ahead.
Go ahead, Mary, you go.
Oh, I was just going to say, I think it's great that you're going to a research conference. It's a great environment to kind of see the nuts and bolts of research projects. If you're too intimidated to ask questions during a talk, you can always go, hopefully there's poster sessions, which I always find are so much more casual. Another amazing resource that you guys have that I didn't have when I was a graduate student, because I'm an elder millennial, is YouTube videos. There are so many, even, college level lectures on things like machine learning, or learning how to code in Python, or just like promotional videos of from journals or people who are just excited about their research will post YouTube videos. And I think I use them. Like I'm always trying to improve my Python coding. So I'm taking some online courses, and I think it's really cool that you guys have that kind of at your fingertips. So that's another way that you can kind of dive in. That's very, I don't know, it's different than going to the journal articles, right? Because you just get to hear people actually speaking about it and using like more casual language.
So I was just going to point out that I know it's human nature to be intimidated to ask questions, but don't. Science advances by asking questions. It doesn't, ironically, I don't think it advances by answering them, but it's more by asking the right ones. And so a key part of your scientific development will be developing the skill to ask questions. And one of the things you should realize is that if you have a question, chances are there are 50% of the people around you have the question, right? And so what you really want to do is start a dialogue always, especially at something like a research conference or in a research meeting. And so asking questions is really the key part of it. And so become an active participant, and that will carry you to where you need to go. Right. So that's what I would say. Don't be shy.
Okay, so I'm gonna the transfer over here, but first, Nicole, I was to give you a second to say something real quick.
Hi, everyone. I'm out sick today, so please forgive my unprofessional look. There's not many folks here, but hopefully people will watch the recording. I continue to be impressed every year with the material science and engineering department. I think it says a lot that you have 3 faculty members and a handful of students here to do outreach. That's like very, very rare, especially for a school as prestigious and elitist as Berkeley. And that, I mean, the slide that Lane shared earlier, I've been on campus 12 years. I've worked with many departments. I've never seen a department express its expectations of itself and its promises to students. Normally we like to talk about what we expect from our students, but I think it says a lot about the culture of this department that we have, promises about access, support, a safe and caring, humane environment, a diverse student body. To articulate that at the beginning of a session, especially for a STEM department, says a lot. And I hope people, as you're thinking about majors and departments, will think about that, because it's a really big deal to me. This is routinely people's favorite webinar, and I just really want to say thank you to our faculty and our students for putting this on.
And thank you, Nicole, and everybody for organizing. And now we're going to hand you over to our very capable students who will give you a different perspective on the department. So thank you all again. And I believe we can, Mary.
One quick thing, don't hesitate to email anyone.
Yeah, oh, that's true.
With questions. We're more than happy to answer them. Like Lane said, we get a lot of emails, but we'll do our best to respond. If we don't respond, if the email scrolls off the bottom of the page, they sometimes get lost, and that happens about after a half a day. So if you don't hear it back right away, give us a day or two and then write again. We won't be offended. And we're happy to help them. All right.
All right. Bye, everybody. Thank you.
Bye, everyone. Thank you so much.
All right, do our MSCA students want to start maybe introducing themselves and then opening up the floor for questions?
I can start. Yeah, so my name is Junho. I'm a second year majoring in EECS and MSc joint major. And I research in like semiconductor and optoelectronics devices.
I guess, I can be the first Daniel to go. My name's Daniel. I was a junior transfer student last year, and I am a senior doing purely MSc. The two research projects that I've been working on since I got here last year have been doing thin film caloric materials, as well as catalyst materials for stuff like CO2 methanation.
Sweet. I will be the second Daniel to go. My name is Daniel Yao. I'm a junior in the MSc department. I'm studying just MSc at the moment. So some of the research projects that I've done in the past were semiconductors and magnetic storage. And also right now I'm kind of working towards the battery end. Right now I'm also working in the nanofabrication lab up here in the northeast side of Berkeley, the campus. So yeah, it's a little bit about me.
Hello, my name is Juditha. I am a recent transfer student. This is my first semester at Berkeley, and I haven't started any research yet. So that's all. Also, just studying MSc, no double major.
Yeah, well, if anyone has any questions or is curious about anything, we're happy to answer anything and give any insight that might be helpful for you guys.
Feel free to speak out. You can also type in your questions in the chat.
Trevor, we have two Daniels here. Which Daniel are you referring to? Hawthorne.
I mean, specialization, as far as like entering the workforce, I have a couple things that I know that I'm interested in, and a couple things that I know that I'm definitely not interested in. I haven't committed to anything yet. I still have one semester and I have some pretty important classes that I feel like will definitely tell me whether, or basically what I want to specialize in. I wasn't sure if, or I'm not sure if you mean like research wise or like future career wise or oh, Interest research. I already, like I said, mainly what I've been doing work in is like energy storage techniques, thermally, materials for thermal energy storage, as well as thermal energy conversion. And that's in the form of catalysts. I worked in it. It was fine. Like, I enjoyed my work there, but I realized that it probably isn't exactly what I want to ultimately go into. And I mean, that's fine. That's kind of the point of trying things out, right? As far as class wise, I'd say Daryl's crystallography class was certainly pretty interesting. That really, I feel like, kind of shaped the conceptual aspect that I found very interesting about MSc in general. And then, like, as far as like practicality wise went, as I started taking more classes, it started to rule things out, and I was like, oh, okay, maybe I don't actually want to go into like computational work, for example. That was like his classes, especially computational related. So but hopefully that answered some of your questions.
Aren't you planning on doing fifth-year masters at Berkeley? It's like, what are you trying to like specialize in when you're doing like fifth-year masters or masters in general?
I mean, yeah, so currently in the process of applying. When it comes to the fifth-year master bachelors, they're pretty flexible. You don't have to like commit to anything before you apply, but they do, you are expected to have some sort of idea of what you would want to go into. As far as like picking a topic, I'm mainly looking into going further into characterization. I think that was one of the fields that, or at least, one of the classes and one of the fields that I took that I was definitely like, this is pretty interesting. And in the research I did over the summer, I managed to do a lot of it, and that was probably the thing that I liked the most about it. And that's probably what I will look into group wise. So there's a ton of MSc research groups, like minors group, as well as, oh God, I'm drawing a blank on his name right now. There's a couple groups that focus pretty hard on characterization related research, and I think currently that's what I'm leaning towards. But again, luckily it's not exactly like binding until you actually start, and then it's like, okay, you gotta go. So that's what I'm currently thinking right now, and then if I take classes next semester, that might change. So but yeah, if anyone, hopefully that answers some things. If anyone has any other questions or questions for Junho, the other Daniel, Yuritsa, yeah.
Hi, Trevor. I guess a lot of my interests to do with like material science kind of stem from my early experience with like thermal energy storage. So kind of how I discovered it was through this internship I was lucky enough to get after my junior year of high school. And basically I was working in this laboratory, which was developing thermochemical energy storage. They were using a ceramic material to essentially use excess heat from, say like solar trapping, and basically that would like convert the ceramic like crystal structure and therefore like store the energy as latent heat. And I thought like that was incredibly useful. And I looked into some research papers, and that's kind of like how I got into mat sci. And kind of ever since, like that's always kind of been the background of a lot of my interests. So when I do like, as I mentioned, fabrication in the nano lab, I'm always kind of like thinking about, how this could like apply to energy conversion, energy storage applications, because like, these are the things that I think will really matter to our generation in the years moving forward. And, I really want to be a part of that fight to progress those technologies. But honestly, like Daniel said, it's all about discovery. And I had no idea about any of the labs, and I probably could not understand any of the work before like, coming to Berkeley and just seeing it for myself. And a lot of it, that discovery process was just looking at, people's research websites, reading a couple abstracts and just, taking some ideas from those research papers, be like, hey, like, can we actually look into these like phenomena, like, what isn't known, what is known. So that's kind of how my interest developed, is sort of a stochastic process, just starting, I think this is really interesting, and then just seeing like, oh, these tangential applications, tangential like, research efforts that like I find personally cool. Yeah.
I think what other Daniel was talking about, reading up on the faculty websites. If you do attend to or intend to attend Berkeley for MSc, definitely take a look at some of those faculty websites. A little bit of effort in looking into what each professor is doing, and what they specialize in can go a long way in knowing which professors you want to reach out, like you plan to reach out to, and also what content that you'll learn in classes you think can prepare you more to enter a potential research opportunity that you're interested in.
That's really well said, Daniel. And I think like you guys like kind of heard like earlier on in this info session, people are very accessible. Like you can email any of these professors their GSIs, and maybe you'll have to like reach out, one or twice or like, 3 times, at worst, but people do get back to you, and they're always really willing to help you out if you have a good idea about what you want. That is one piece of advice I would give, is just being really decisive and saying, these are some topics I'm interested in and I'd like to learn more about them. Just going out and like putting that like effort out there early on is really helpful, and that's kind of what drove me forward, at least.
Yeah, even if they don't respond in email, you can just go to their just visit their office and like for office hours or something like that, because there aren't a lot of MSc students in Berkeley. So their office hours are not that crowded, so you can just go to any office hours of the professor that you're interested in, and you can just talk about their research, and you might get research opportunity from it.